How a one-way roller clutch works is actually fairly simple. So if we take a roller bearing, okay, so a cylinder, I'm just going to draw a circle here, and it's contacting a rotating inner race, and let's say this inner race is rotating clockwise, well, this roller bearing is going to want to move in this direction. Okay, and then if we rotate the inner race in the opposite direction, well, then this roller bearing is going to want to rotate with it. Now, how a one-way clutch works is instead of the outer race being a nice smooth arc as well, which would just be a roller bearing, to make it a one-way clutch, let's draw a wedge. So if I draw a wedge here, so you can see how that's tapered, when rotating clockwise, well, this roller is now moving away from the wedge and is going to be nice and loose, which means the inner race is going to be able to rotate. And let's just say this outer portion, this outer wedge, is held stationary. Well, this inner race is going to be able to rotate no problem. Now, if we then rotate this counterclockwise, and again, this roller is now going to want to go in this direction, what's going to happen is it's going to move into this smaller area, this wedge, okay? And what's going to happen? Well, if this outer race is held stationary, well, this inner race is going to jam. It's going to move slightly until this wedges and is now going to stop moving. All right, so that's all that's really happening. When rotated clockwise in this situation, this roller is going to be loose, allowing that inner race to rotate. Now, if we try to rotate the inner race counterclockwise, this roller is going to jam in the wedge and our inner race is not going to move. Okay, so here is one that you can actually see quite easily because it's so large. We have our inner race. We're going to call this our outer race. And here you can see those wedges, this taper. Here's our roller sitting inside between the two races. And then we have a return spring, or not a return spring, this accordion spring. Now, the roller will allow for free movement if I rotate it clockwise in this condition. Okay, so clockwise in this condition, if I rotate this inner race, all of these rollers are moving against the spring, allowing for free movement, okay? Because these rollers are all moving into this larger gap area. Now, if I try to rotate this inner race counterclockwise, I can't, because when I try to rotate this inner race counterclockwise, all these rollers are moving into the smaller gaps of these wedges, jamming the inner and outer races to prevent them from moving at all. Okay, so basically, look at it like this. If I rotate in this direction, our two races are able to be move independently. If I rotate or try to rotate this inner race in this counterclockwise condition, well, now what's going to happen is either if this outer race is held stationary, maybe to the case of a transmission, well, now it just jams and locks, or maybe we have it so that when we try to rotate in a counterclockwise condition, all this rotates as one unit. Okay, so no matter what, they jam together, they get locked together. Free, locked together, okay? And then back to free. So hopefully this makes sense and kind of helps with understanding how these work. And just to touch on these accordion springs, the whole purpose of these accordion springs is to make sure that all these rollers are in constant contact with the inner and outer race so that we have a very precise, quick engagement of our one-way clutch. All right, if you have any questions, leave a comment.